right, guys, we're going to learn a little bit about interval notations today. We're going to review some facts that we used on the previous unit. So we use interval notations with inequality symbols. So this thing here, this left hand, is just a symbol here is to help you remember. I can make a L on my left hand, and I can change that L into the less than symbol. So just remember, if I have x is less than 4 here, we, on the last unit, put the 4 on one of the tick marks. This was an open circle, and it's going to be pointing to the left to show all the numbers less than 4 as a solution. So if the left hand is the less than, then your right hand is the greater than. So in this example, x is greater than 2. Well, since I already have 4 on this number line at a tick mark, 2 would have to be 2 units behind or in front. And this is also open, but because it's greater than, it's pointing to the right. So just kind of want to recap that real quick and just remember some rules. Over here in this example, they're showing you 6 is greater than 3, and that is a true statement. Then they're just showing, well, what if I multiplied each side by 2? Well, 2 times 6 is 12. 2 times 3 is 6. 12 is still greater than 6. Well, what if we divide each side by 3? Well, 6 divided by 3 is 2. 3 divided by 3 is 1. 2 is still greater than 1. So the symbol is still staying the same. Now, what if we multiply by a negative integer? Negative 2 times 6, that makes it now a negative 12. Sorry, I just fixed that. Negative 12 on this side, on the left side here. And then I have negative 6. Well, negative 2 is not greater than negative 6. It's less than. Same thing if I divide, this becomes negative 2, negative 1, negative 2 is less than. So we just needed you to remember, if you multiply each side by a positive, the sign, the inequality sign here, stays the same. It didn't change. But if we multiply or divide each side by negative, we end up flipping the sign. So right here we flipped when we had multiplying or dividing by negative. So we're just going to recap that. So now we're just going to add the interval notation, because we're taking a previous skill, which is solving inequalities using the inequality symbols and graphing them, and now showing the solution with interval notation. So I'm just going to hit the key points. Interval notation is just basically using parentheses and brackets to show where the graph starts and ends. Parentheses is used with open circles. Like when we graph, we have an open circle when it's less than or greater than. But then if it's a closed circle, when it's like less than or equal to, okay, or greater than or equal to, that's when we have a bracket. Now, we always use parentheses for infinity. Infinity, for example, if I have, let's say I had an open circle pointing to the right. Everything to the right are positive numbers on the number line. So that's trying to get you to understand that that indicates basically a positive infinity. If I have open or closed, it doesn't matter. But if the line of our solution is pointing to the left, that's a negative infinity. Anytime I see or use infinity, so I have an arrow, we're going to use parentheses with that. We're just going to practice doing the interval notation. I'm going to give you the graphs, and we're going to come up with the notation. Now, start to end, right? So when we're graphing this arrow, this dark arrow here, I still read it, even though it's pointing to the left, I read it as left to right. I'm reading everything I read left to right. So it starts here, okay, and it ends at this open circle. Well, because it starts pointing to the left, that is a negative infinity. It's an open circle at 3. So I start, oops, I forgot to put my T on my start, sorry. So when I write this, we're starting at negative infinity. Any infinity has a parentheses. So negative infinity, so we start, comma, where we end is at 3. And because it's an open circle, we use parentheses here. Okay. So on number 2 here, if I look closely here, let me fix my font. It's a closed circle here. This is where we're starting. We're starting at 0. And it's going to end with this arrow pointing to the right, which is positive infinity. So since we have a closed circle here, since it's closed, we're going to start with a bracket, because it starts right here at this closed circle, bracket 0. And then since it's ending over here pointing to infinity, we put our positive infinity, and then we close it with parentheses. Okay, so on our next page here, all I wanted us to do is just kind of review graphing and then coming up with the interval. Graphing and then coming up with the interval. So if I'm graphing the first one here, we have x is less than or equal to -6. I just need to put a tick part for my -6. It's going to be closed because of that inequality and pointing to the right. So when I do my interval notation, sorry, this is where it starts at the close. It ends here. It's ending at a negative infinity. Since it's starting at a closed circle, that's going to be bracket -6, comma, negative infinity, parentheses. Anytime I have a bracket in our interval, we have a bounded interval. Meaning the bracket is saying it's bounded, it means it's including that point. Okay, it's including that value. If I have just parentheses, then it's unbounded. So on number 4 here, x is less than 12. I'm just going to put my 12, tick mark. It should be open, pointing to the left. So it starts, my solution starts here, pointing to the left, which is negative infinity. It ends at the open circle. So this would be parentheses, negative infinity, comma, it ends at 12, and that was open, so that's parentheses. Since we have 2 parentheses, this is unbounded. So I want you to try the last one, okay? And then let's just check, give you a minute to try and check, and then we're going to get into solving. All right, so for the last one, hopefully we have the following graph pointing to the left, starting at -5.5. And then our inequality, since it starts, it's pointing to the left. This is negative infinity and ends here at the closed dot, left to right. So we should have negative infinity, comma, -5.5. All right, so now we're just going to put it all together. Use our previous skills for solving equations or inequalities, it's the same steps. Graph it, and then do our interval notation. So number 6 here, because I see parentheses, the first step is to distribute. The new equality would be 4x plus 12 is greater than -24. Okay, 4x plus 12 is greater than -24. The goal is to get the x term, which is just 4x, isolated. Here, with the x term is a plus 12. That's a constant. So to eliminate that constant, we need to do the opposite, which means we're going to have -12. Now we have 4x is greater than -36. I'm just going to rewrite this up top so I can show you the next step. All right, so next what we need to do is we have a coefficient, a number in front of this x, which is 4. We need to divide both sides by that coefficient of 4. That's going to cancel that 4, get the x, isolated, and it's now greater than -9. So that's our inequality. So I'm just going to take this now, graph it on this number line. I just need a -9 at a tick mark. Greater than is going to be open, pointing to the right. So I can physically see that this is where it starts, or I can put it up there, but it starts as a -9 and it's open here, and it ends at this negative infinity. So this would be parentheses, -9, comma, I said negative infinity, that's positive, sorry guys, comma infinity. And that's always parentheses whenever dealing with the infinity symbol. Now on 7, same steps, same 5 steps we always do. No distributing, no like terms, but we now have variables on both sides. So we should start with the smallest variable, which is this 2x. I'm going to subtract the 2x. When I do that, I'm going to cancel that, leaving, don't forget your sign, a -1 is less than or equal to 3x plus 20. Then I'm going to isolate this x term by eliminating the constant plus 20. To do that, we have to subtract 20. And when we do that, I'm going to rewrite what we have. We have -21 is less than or equal to 3x. The 3 is the coefficient. That's the number in front of the x. That's what we have to eliminate. So we have to divide by 3. That cancels, giving us -7 is less than or equal to x. But when I graph this, because the x is not on the left side, I'm going to go in the opposite direction. Because if I were to switch this around, move the x to the left, move the number, -7 to the right, that means I have to switch the inequality. So if I rewrite it as x is greater than or equal to -7, we're starting with a -7. It's going to be closed, pointing to the right. So it starts at a closed circle, so that's a bracket. The -7 comma is pointing to the right. That is positive infinity. So comma infinity, parentheses. Now for 8, the first step, because we have these parentheses here, will be to distribute this -3. So this becomes 5x minus 3x, then minus 18, because a negative times a positive is -18. Greater than or equal to 34 minus 6x. You still have to rewrite everything else. All right, so now we have some like terms here that we have to combine. 5x minus 3x leaves me with 2x. So I have 2x minus 18 greater than or equal to 34 minus 6x. I would eliminate the smallest variable, which is this minus 6x. Do the opposite, so plus 6x to eliminate it. Plus 6x. Now I'm going to just rewrite up here. Now I have 8x minus 18 is greater than or equal to 34. And then we're going to need to isolate the x term by adding 18 on both sides. So our 8x is greater than or equal to 52. I'm going to divide that by 8 to get rid of that coefficient. This comes out to be x is greater than or equal to 6.5, which is the same thing as x is greater than or equal to 13/2. We want you to be able to do both answers. Let me fix that, sorry. Yeah, we want you to be able to give the fraction answer. So either way, I just want to get that fraction 13/2 at one of the tick marks. We need to have a closed dot because it has that equal to sign, and then it's pointing to the right. So closed dot means we're going to have a bracket to start with. We're going to have that 13/2, sorry, 13/2, and then it's going to be positive infinity. All right, so let's just talk, let's get that down. So about the last two, I'm going to star these because we have some special cases which correlates with the last section. If I distribute this 2, I get 12x plus 18 is less than or equal to 12x plus 19. Well, on here, since they're both 12x, I'm going to do the opposite, which is to subtract them. They're both going to get eliminated. And that's going to leave me with 18 is less than or equal to 19. This is a true statement because it's less than or equal to. So 18 is less than 19, so that's true. And whenever we have true, we have all real numbers, or you can say infinite solution, or infinity. So infinity on means every number, all real numbers means every number on the number line is a solution. Now to show that, we have to have a double arrow, an arrow pointing to the left and to the right, because it keeps going to indicate that. Well, since we have a double arrow, it would start, we go left to right, so start and end here. So starts at a negative infinity, ends at a positive infinity. To show that, that would just be parentheses, negative infinity, comma, positive infinity. Okay, so you can still have a true statement, which is our real numbers. Now, if you get a false statement, and that's an example here on 10. So let me show you here. If we distribute first, that's 12 minus 4u plus 4u is greater than 16. Oh, that's a u, sorry. It's supposed to be a u. All right, right here, negative 4u plus 4u, those cancel, that becomes 0. 12 is greater than 16, that's a false statement. 12 cannot be greater than 16. So that's no solution. That's that empty set that we use here. So there's no number that exists on the number line to make this true. So the interval does not exist. We write D-N-E. All right, thanks for getting this done. We're going to let you go on to the homework 10 with practicing what we just did on our notes. All right.